with section 7.3, we start putting to use some of the things that we've been learning about linear programming, which is essentially just graphing systems of inequalities. So just a reminder, our goal for optimization is to find either the maximum or minimum value of whatever objective function we have been given: profit, cost, revenue. And then we have our steps for solving a linear program problem graphically. We set up the problem. When we set it up, we need to identify our variables. That's going to define our unknowns. We need to identify our objective function. Tells us what we want to maximize or minimize, and remember it's in the form of z equals. And then finally we need to identify our constraints. We only have one objective function, but we can have multiple constraints or limitations that give us our boundaries. Those boundaries allow us to graph our feasible region, and we do that by graphing a system of inequalities. Graph our constraints, shade the correct sides. We find our corner points from that feasible region, and then finally plug each point into our objective function to establish our maximum or minimum value, whichever way we need to optimize the problem. Okay, so we're going to kind of walk through the parts of this that we haven't done yet by doing piece by piece. Our first step, 1A, is to identify our variables. So let's do that for these two problems. A canoe requires 8 hours of fabrication and a rowboat 5 hours. The fabrication department has at most 110 hours of labor available each week. Well, we are going to use X and Y to set up our graph. So X will be our horizontal axis, Y will be our vertical axis, and there's nothing magic about which one is which. Usually we make whichever is mentioned first our X value. So in this case, X is going to represent the number of canoes. We are told that they take 8 hours to put together, and Y is going to represent the number of rowboats. And we know that they go together a little faster than canoes. On the second one, a candidate can afford to spend no more than $9,500 on radio and TV advertising. Each radio spot costs $250. Each TV ad costs $750. Now, we've been given more information than just our variables. We've been given some constraints and some other information, but all we're being asked for this problem is to identify our variables. Well, we have two different types of ads listed. The first one listed was radio, so we're going to make X represent the number of radio ads, and Y represent the number of TV ads. Alright, for this next couple of problems, we're going to focus on constraints, on our limitations. So let's see what we've got. The liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, 90 units of vitamin C daily. A cup of dietary drink X provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of dietary drink Y represents 60 calories, 6 units of A, and 30 units of vitamin C. We're told to set up a system of linear inequalities that describes the minimum daily requirements for calories and vitamins, letting X equal the number of cups of drink X and Y equal the number of cups of drink Y. Write all the constraints as a system of linear inequalities. Now, we're not going to, well, we may actually do all of that, but we're going to focus on identifying our limitations. Lots of information here, but our focus is our constraints. I know that, let's see, liquid portion of a diet is to provide at least 300 calories. That's my first constraint. The liquid portion of my diet needs to produce at least 300 calories. Which inequality do I use? Well, at least means that much or more than, so greater than or equal to. Then we're going to kind of, this at least carries over at least 36 units of vitamin A, so at least 36 units of vitamin A, and then at least 90 units of vitamin C. Vitamin C. So those are our main constraints. We're talking about drinking X and Y, probably numbers of ounces, right? So is this system going to be restricted to quadrant 1? Well, yeah, we can't drink a negative amount, so X is going to be greater than 0 and Y is going to be greater than 0. All right, let's see what we've got on the next one. Yeah, let's just go on from there. Let's see what we've got on the next one. We're just going to identify constraints for these today. I have more on my key, but we're just going to do constraints. Mrs. White wants to crochet hats and afghans for a church fundraising bazaar. She needs 6 hours to make a hat, 4 hours to make an afghan, and she has no more than 66 hours available. She has material for no more than 14 items, and she wants to make at least 2 afghans. Let X equal the number of hats, Y equals the number of afghans, and we want to write systems of inequalities that describe these constraints. So, if X is the number of hats, and Y is the number of afghans. Now let's go back up to our information and see what we've got. She needs 6 hours to make a hat, 4 hours to make an afghan, has no more than 66 hours available. So it takes her 6 hours to make a hat and 4 hours to make an afghan, and she has no more than 66 hours available. So that means she can do less than 66 hours up to, so less than or equal to 66 hours. That's our first constraint. Our second constraint is about materials. She has material for no more than 14 items. So the number of hats plus afghans has to be less than or up to. So less than or up to 14. That's my number of items. She wants to make at least 2 afghans. So Y is afghan. So Y needs to be at least. So at least 2 means going to be greater than or equal to 2. How about the number of hats? Well, it doesn't say, but she can't make a negative number of hats. So X is going to be greater than or equal to 0. And there's my system of constraints. So as I look at this, we didn't do a real thorough job on the last one with our system of constraints, did we? So let's see if we can do better. We did the right side here, but we didn't do the left side. X is the number of cups of drink X, Y is the number of cups of drink Y. So if I drink X and Y, however many cups of X, however many cups of Y, I need to have at least 300 calories. X plus Y needs to give me at least 36 units of vitamin A. X plus Y needs to give me at least 90 units of vitamin C. And I can't drink negative cups of liquid. So I have to drink 0 or more cups of each X and Y. There's a better setup for that system of constraints. Okay, I feel better about that one. Let's look at the next section. These two, we're going to identify the objective function. These two, we're going to identify the objective function. So we're taking each of these piece by piece. We identified the variables, we identified the constraints. Now for these two, we're figuring out what is my objective function. A steel company produces 2 types of machine dies. A machine die is something that makes parts. Part A and Part B. The company makes a $2 profit on each Part A. It makes a $6 profit on each Part B. Let X be the number of Part A, so there's my first variable, and Y be the number of Part B produced in a week, so there's my second variable, and I want to write an objective function that describes the total weekly profit. Now, profit. Do I want to maximize or minimize profit? Profit is how much money we actually make, not the income, but how much that income is above cost. So we want to maximize that because we all want to make the money, right? Well, how much money are we making? That's what we're going to focus on. X is part A, Y is part B. We make a profit of $2 on part A, and we make a profit of $6 every time we do a part B. I didn't use the right variables though, did I? Honestly, I would probably keep this as A and B, but as we take it to our graph, it will be easier if we do it in terms of X and Y. So let's switch that out. Okay, a dietitian needs to purchase food for patients. She can purchase an ounce of chicken for 25 cents, an ounce of potatoes for 2 cents. Let X be the number of ounces of chicken, and Y be the number of ounces of potato purchased per patient. Write the objective function that describes the total cost per patient per meal. So what do we want to do with cost? Do we want cost to be high or cost to be low? Well, we want to minimize our cost. So we're buying chicken and potatoes, and I'm going to keep it straight this time. Chicken is X, potatoes are Y. Chicken's more expensive at 25 cents. So 0.25 times X for the cost of the chicken plus 0.02 Y for the cost of the potatoes. Alright, short and sweet because we're not doing the whole problem. We are going to do a whole problem together before we're done. Now let's start putting these three pieces together. We're going to identify the variables, objective function, and constraints. So take a second and read that, and then we will see what we can do. So what are our unknowns? Our variables, X and Y. Well, we have two suppliers, supplier 1, supplier 2. Let's just go in order. X is going to represent supplier 1. Y is going to represent supplier 2. What am I wanting to maximize or minimize? Well, I want to know how much can be ordered from each to get at most 100 gallons of oil with maximum detergent. So I'm trying to maximize the detergent content. So detergent content is what I'm interested in for this objective function. Well, what's my detergent content? Right here. That's my detergent content. Now, what do we do with percentages? We typically turn those into decimals, right? So let's go ahead and do that here. We've got 0.039x plus 0.033y to represent our objective function based on detergent content. Well, what are our limitations? So we want to maximize the amount of detergent in our 100 gallons of oil, up to 100 gallons of oil. And we know that, really, if I just did all this one, it's going to have more detergent content, but this supplier can only give us 45 gallons. I guess maybe per week, per month, whatever the order term is. Supplier 2 can give us more, but the detergent content is lower. So what's going to be our best bet? Well, let's start setting up some constraints. Supplier 1 can supply at most 45 gallons. So 45 is the upper limit. It can do less than that or up to that. So X is supplier 1. X is going to be less than or equal to 45 gallons. On the other hand, Y can do at most 67. So Y is going to be less than or equal to 67 gallons. We're going to order up to 100 gallons of oil. So together, we want less than or equal to, at most, 100 gallons of oil. So those are my constraints. Do I have any additional constraints? Well, can I order a negative amount of oil? No, right? It's going to have to be positive. So I know that I am restricting my feasible region to the first quadrant because I can't order a negative number of gallons from either supplier. So we are restricting to quadrant 1. Okay, great. Let's look at number 2. A breed of cattle needs at least 10 protein and 4 fat units per day. We have 2 types of feed type 1, feed type 2. Oh no, this is all feed type 1, this is all feed type 2, and our objective right there. So, unknowns. Feed type 1, feed type 2. Feed 1, feed 2. Objective. We want minimum cost. We want to minimize cost. Well, how are we going to do that? Feed type 1 is X. We're going to do feed type 2 is Y. How much do these feeds cost? Because that's our objective that we're after. Well, feed type 1 is $3 a bag. And feed type 2 is $2 a bag. There's my objective function. Let's figure out our constraints. We have information about protein and fat for each type of feed, as well as that cost information. We've already used the cost information. So let's put together our protein information all in one equation, or one inequality, and then our fat information in one inequality. Okay, we know that total we need at least 10 units of protein for our cows. So at least 10 means 10 is the lowest. I can have more than that. So at least 10 units of protein. The first feed type gives us 6, so that's 6x. The second feed type provides 2, so that's 2y. So the combination of the 2 types of feed together has to be at least 10 units of protein. Then we have fat information, and the cows need at least 8 units of fat. So this is my protein constraint, this is my fats constraint. The first feed has 2 units of fat, so that's 2x. The second feed has more fats. It's fattier. It has less protein, but it has more fat. Any additional constraints? Well, we've got money information, but that's addressed over here in our objective function. Do we restrict quadrant 1? Absolutely. We can't feed a negative amount of feed of either type. So both x and y have to be at least 0. So there are my 4 constraints for this problem. All right, now we're not gonna actually graph and put everything together for any of those. We're gonna do a separate problem. This last page of notes. We're gonna do all the things here, put all of our steps together, and we're gonna figure out. Well, let's see what we're going to figure out. A student earns $10 an hour for tutoring and $7 an hour as a teacher's aide. Let X be the number of hours spent tutoring and Y be the number of hours spent as a teacher's aide. So, tutor, aide, tutor is going to be X, aide is going to be Y. You earn $10 an hour for tutoring, $7 an hour for being a teacher's aide. That's the information I have so far. To have enough time for studies, the student can work no more than 20 hours a week. So that's some interesting, there's a limit, there's a constraint. The tutoring center requires that each tutor spend at least 3 hours a week tutoring and no more than 8 hours a week. So we have a lower limit and an upper limit on the number of hours you can tutor. What's the maximum amount that the student can earn in a week? How many hours do they have to work as a student aide and a tutor? Okay, so we are being asked to maximize the amount that the student can earn. That's going to be my objective. This last question really asks me to interpret my outcome, my maximum value. How many hours would they work to get that maximum amount of money? How many hours would they work as aide and how many hours as a tutor. So this bit is asking me to interpret my solution. Okay, so my objective is to maximize my earnings, and right here I want my objective function Z to be the maximum value when I make $10 an hour as a tutor and $7 an hour as an aide. So that's my objective. Now let's figure out our constraints. To have enough time for studies, the student can work no more than 20 hours a week. So tutoring and being an aide has to be no more than 20. So up to or equal to 20. My next constraint, the tutoring center has requirements. They have a lower limit of 3 hours and an upper limit of 8 hours on tutoring. So tutoring is X. X has to be at least 3. So greater than or equal to 3 hours, no more than 8. X has to be less than or equal to 8 hours. Do I have any limits on the hours they can spend as an aide? No, we weren't given any information on that. So we don't have any additional things here, except, am I limited to quadrant 1? Well, yeah, because we can't work a negative number of hours, so Y has to be at least 0. Now, I don't have to say X has to be at least 0. X has to be at least 3. It has a higher lower limit than Y. All right, so there's my system of constraints, my 4 constraints that I need to get on my graph. These are all going to be horizontal or vertical lines. This one is going to not be horizontal or vertical, but I'm going to have my maximum value of 20. If I plug in 0 for X, Y is 20. If I plug in 0 for Y, X is 20. So I know that I need to be able to count to 20 on my graph. To make that happen, let's plan to count by 2s. So go ahead and set up your X and Y axes. If you drop it in a little bit, it lets you have a way to number things. So here's X, here's Y. X is going to be the number of hours tutoring. Y is the number of hours as an aide. And if we count by 2s, this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Same across the x-axis. Okay. Let's get our constraints graphed. I know that Y is going to be greater than 0. So that Y greater than 0, that puts me up there into quadrant 1. Y greater than 0. X is going to be greater than 3. So let me get a little longer straight edge here. 3 is between 2 and 4, so I didn't think that through super well. Let's do 3 is halfway between 2 and 4. I drew on my straight edge instead of on my paper. That is less than helpful. Okay, so this is X greater than or equal to 3 is going to move that way. X has to be less than or equal to 8. So this one's a little easier. That's one of my bars here. X has to be less than or equal to 8 is going to move back this way. So I know right off the bat that I'm going to be between these two limits on the number of hours I can tutor. That, if we number these 1, 2, 3, 4, this is boundary 1. Nope, that's not boundary 1. That's boundary 2. Boundary 2, boundary 3, boundary 4. We need to graph boundary 1. My first boundary line, X plus Y equals 20 as a boundary line. Remember, I said if you plug in 0 for X, you get 20. If you plug in 0 for Y, you get 20. So I can graph it using my intercepts. So 20, 0, 20, and 20, 0. There is boundary line 1. All right. Now I know that I've got to be greater than 3 hours of tutoring, less than or equal to 8 hours in tutoring, and a positive value for y. So I've already identified I'm going to be in here in this skinny column right here. What I need to know is, according to this first boundary line, am I going to be in this area or this unbounded region up above? So let's figure that out. Let's test a point for our boundary line. For this boundary line, I can test the origin by plugging that into that inequality statement. There's my inequality, 0 and 0 is 0, less than or equal to 20. That is a true statement. So this boundary line is going to include the origin. So I'm going to interested in what is below this boundary line, but remember we already checked and we know we need to be between these two. So if I'm between those x values and below that boundary line, I'm interested in this region. So this is a bounded feasible region, which means it's going to have both a maximum and a minimum. But we are only interested in maximum earnings. So let's set this up. We are going to maximize z equals 10x plus 7y. We've got 1, 2, 3, 4 boundary points. Let's go ahead and label those A, B, C, D as my corner points, and find those coordinates. A, B, C, D are my 4 corner points. Well, A is right here. It's on the axis. That's super easy. We moved over 3, so that point is 3, 0. A is 3, 0. B is, B's a little iffy. So let's step aside from B. C is a little iffy. It looks like it's at 8, 12, but we are not positive that it hits at 12. We know it's on 8 as the x-coordinate, but we're not sure about the y. D is on the axis, so we know that it is at 8, 0. All right, so let's start there. Let's go with what we know for points B and C. On point B, I know that my x-coordinate is 3. I don't know the y-coordinate. For point C, I know my x-coordinate is 8. I don't know the y-coordinate. How can we figure out our missing value? Well, we could solve the systems, or we could just take our boundary line equation. X plus y equals 20 is this boundary line here. Plug in that value for x. So that would be 3 plus y equals 20. Or if I subtract that 3, y is 17. And here, 8 plus y equals 20, plugged into my boundary line equation. Subtract the 8, and I get y is 12. So that was a lot quicker than having to solve the system of equations, right? So I take all the information that I know to make things easier on myself. I know for a fact what that x-coordinate is because those are nice horizontal lines. And so I make use of that fact as I'm figuring out what it is that I need. Okay, we are going to find each of these objective function values, where our objective function is our our earnings function. So we're maximizing earnings. Here we have 10 times 3 plus 7 times 0. That's going to be 30. Earnings would be $30 there. Here we have 10 times 3 plus 7 times 17. Oh, I need to plug that 7 times 17 into my calculator and add it to 30. I get $149 there. Here I make $10 for 8 hours of tutoring plus $7 for 12 hours of being an aide. Calculator help. I see that I would make $164 that way. If I only work 8 hours as being a tutor and I don't work as an aide, I only make $80. Okay, so I'm maximizing my earnings, and this value right here is the maximum earnings. Now, the last thing, that last question asked me to interpret that. What does that mean? So that means that I get my maximum earnings of $164 if, go back to your ordered pair, you tutor for 8 hours and work as an aide for 12 hours. That's how I interpret my solution. So I found my maximum, but then I have to go back and stop and interpret the solution and tell what that means. Now, if I'm just looking at my graph, I would have expected B to be my maximum. For each of these points, I'm working 20 hours, which is the maximum number of hours I can work. B is higher, so it looks like it should be the maximum, right? Except when I go to my objective equation, objective function, I see that I make more at those tutoring hours. So the more hours I can tutor, the more money theoretically I'm going to make, right? So right here, this ends up being my max, even though it's not the highest point on the graph. This is a good example of what I was talking about when I said you can't just look at the graph and assume you know what your corner point is that you're after.